All right, this is going to be our help video for the homework about simplifying single radicals. I'll start on this table here. This is the table I had you copy down to help you simplify single radicals. And the reason that it's so useful is because these numbers, based on the column that they're in, when we take a square root or a cubed root or a fourth root, we get an integer answer. So this is the squared table. So if I squared all of these, or if this is, these are our perfect square numbers. If I took the square root of all of these, I would get integers like 1, 2, 3, square root of 14 is, or square root of 16 is 4, square root of 25 is 5. In fact, it just points back to this column here. This column over here is our list of cubed numbers. So if I took the cubed root, is how I take these numbers back to my list of whole numbers. So if I'm dealing with square roots, I should be looking in this column here to help me out. If I'm dealing with cubed roots, I should be looking in this column here to help me out. All right, let's get into some examples. Number 1, I'm taking a square root of 96, b. Now I look into my column of squared numbers, 1, 4, 9, 16. The biggest number that'll fit into 96 evenly is 16. So I'm going to rewrite this as 16 times 6 times b. All right, now I'm going to use the product property of radicals to split this up. Square root of 16, square root of 6b, and then that's going to become 4 root 6b. Square root of 16 is 4. Let's go number 2. Number 2's got a squared underneath it, so that's going to change things just a little bit. I can split this in the square root of 150 times the square root of n squared. And that square root and that squared are going to cancel out. I'm going to be left with just an n. For the square root of 150, I've got to figure out the biggest number that'll go into that evenly. 1, 4, 9, 16, 25 will go in evenly. So I can split this into the square root of 25 times 6 times n. Bring that over here. That's going to be the square root of 25 times the square root of 6 times n. Square root of 25 is 5, so 5 root 6 n. And I'm just going to rearrange that so that my radical comes last. 5n root 6. All right, number 3 is a little bit more complicated yet because we've got a number out in front. That 32 can be split into a 16 and a 2, so now I've got negative 4 square root 16 times 2. And I'm going to expand the k to the third as k times k times k. All right, this can become negative 4 square root of 16 times the square root of 2 square root of k times k times k. All right, in this next step, square root of 16 is going to become 4. Square root of 2 will have to remain like that. But I can package 2 of these k's together, make it the square root of k squared times the square root of k, so that I can use power negation to get rid of that squared there. All right, combine these two 4's which are being multiplied. We got negative 16. Let's bring that k to the front. K root 2 root k. And now we can use that product property of radicals backwards. I've got 2 square roots being multiplied. I can just write that as 1 squared root negative 16k square root of 2k. And we'll put a box around that. That's all for number 3. All right, number 5 gives us a fourth root. So now that I'm looking at a fourth root, I need to be thinking about these numbers here. 1, 16, 81. Can I fit one of those numbers into 80? And I believe 16 will fit in evenly. 16 times 5 is 80. So I'm going to rewrite this as the fourth root of 16 times 5. And then that x to the fifth, I'm just going to write that out. It's 5x's. All right, so this is a fourth root. So I want to package these x's together in groups of 4. So now I've got the fourth root of 16 times the fourth root of 5 times the fourth root. I'm going to make this an x to the fourth times x. So I'm grouping together x's so that now I'll be able to use power negation. The fourth root of 16 is just 2. Fourth root of 5 is just going to have to stay like that. This here is going to cancel, and I'll just have an x times a fourth root of x. All right, let me rearrange this so that everything that's underneath the fourth root is together. This will become 2x, fourth root, 5x. Put a box around that. And let's see, that's for number 5. Let's just see if that's right. 2x, fourth root, 5x, yep. Okay. Let's look for one more hard one. Let's do this one here, because we got something to the power, or a seventh root. We don't even have a column for x to the seventh here. So what we're going to do is we're going to quickly make an x to the seventh column. 1 to the seventh is 1. We don't really need that because that won't help us simplify. 2 to the seventh. I'll need a calculator for that. Two power 7 is 128. And we'll do 3 to the power of 7, but I think by now it's getting too big to even be usable. 2,187. So the only real candidate is this 128. And if it can fit into that 768 evenly. So let's look at that. 768 divided by 128 equals 6. So that means that this can be rewritten as the seventh root of 128 times 6. That x to the ninth, I'm going to repackage it as an x to the seventh times x squared. Notice there's still 9 x's there. We've just split them into a group of 7 and a group of 2. All right, the seventh root of 128, that's going to be 2 times the seventh root of 6 times the seventh root of x squared, or x to the seventh times the seventh root of x squared. That's going to cancel. That's going to become a 2. So we got 2 seventh root 6 times x times the seventh root of x squared. And we'll repackage that all. It's 2x seventh root 6x squared. Final answer. 2x seventh root 6x squared. Yep. All right. Make sure you write good New Year's resolutions in math for question 13. And that's all I've got for this homework here. As soon as I can find where I sign up. Where did I just... There it is.